Okay, guys, I'm back at it again. Um, so next we're gonna be doing division of polynomials, but before I get into that, and just as a disclaimer, this video is gonna be posted on YouTube. It's public. So for all you haters out there, this is just for me and my students. So it's raw, you know. Sometimes I may not make scholastic mathematical references. So, for any of you critics, you can keep your opinions to yourself, but it's fine if it'll elevate me and help me be better. However, this is for me and my students. I haven't found a way yet to make it private so that I don't have to send individual. Why am I going into all of this? Listen, if you look at it and you like it and you learn something, good for you. Back to business. Good. All right. So, but before I get into division of polynomials, I missed talking about the use of scientific notation. And according to your text, it says in scientific notation, a number is expressed as a product of two factors. They're using my favorite words here. Product of two factors. One of the number is between 1 and 10, and the other the power of 10. So for example, it looks something like this. If they want you to convert this whole number into scientific notation, what am I saying? Notation, right? It'll be a number between 1 and 10 times some number with raised to the power of 10, an exponential of 10. So what that means is that you will not, if you have, let's say for example, okay, that number was 340,000 and they wanted you to write it in scientific notation, and that was 3.4 times 10 to the fifth power. So actually how they got that is that the decimal place, which is usually at the end of a whole number, but the book did not describe it as that. The book said something totally different that I'm not really happy with that explanation. But you can read it, and if you understand it, good for you. But what I show students here is that a decimal point of a whole number is always at the end. So we would have to move 1, 2, 3, 4, 5 places. See that? 1, 2, 3, 4, 5 places. Okay, I move 5 places right to get to my 3.4. Hence, that's where I got my power, right? To the fifth place because I moved 5 places. Right, that's what I did. I moved 5 places right. So my solution here is 3.4 times 10 to the 5. Now, the question would be, a lot of times it confused students, and even in the past, it confused me until I studied this more in depth, is that, the question would be, well, why can't I move it 1, 2, 3 places and call this 340 times 10 to the 10 cube, right? So actually, scientific notation, remember it clearly said is that is a product of two factors, and that the first factor is usually a number between 1 and 10. And as you can see, 3.4 is between 1 and 10. So this would not be correct. All right. So when we have whole numbers, so here we have another example. We have a big exorbitant number there. Is that 98 million? Yeah. I don't know. Anyways, so 98, 1, 2, 3, 4, 5, 6, blah, blah, blah. All right. If we were to convert it to scientific notation, yes, we would have to go all the way to the 9.8, and it's still less than 10. So this would actually be 9.8. Let's see how many zeros we move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So that'd be times 10 to the 10 power. Now, why are we using 10? Why are we using to the power of 10? Where did they get that from? Remember, each place value is an exponent of 10, right? Remember that again. Each place value is an exponent of 10. And when it's a decimal, it's 1/10, right? So when you're doing whole number, your place value goes up in tens, like tens, hundreds, thousands, 10,000, etc., etc. So when we're doing place value, it goes up in tens when working with whole numbers. So what happens when we're working with decimals now? How do we write decimals? So this is whole numbers in scientific notation. I'll just put SN for short. Whole numbers in scientific notation. Okay, SN for short. So how do we write decimals in scientific notation? Make up my own fancy acronym there. Well, not necessarily an acronym, just initials. So here we go. Here we have an example. 0 point, and these example could be found in your text. Remember, I'm just doing the example to be conservative so you can capitalize on actual questions that you have right here so you can work out. All right. So here we have a really big decimal number, which really indicates it's small in value. The bigger the decimal with zeros is smaller in value. So this is how many zeros here? 1, 2, 3, 4, 5, right? I think so. It's 1, 2, 3, 4, 5, 6. Is that 6? Yep. 1, 2, 3, 4, 5, 6. 5, 6, 7. So here we go. Again, the same rule applies, right? Your point has to be between 1 and 10. So we're going to go now. So remember, for whole numbers, we started from the right and we went left, right? Started from the right and went left. So guess where we're going to start our decimal? We're going to start left and go right, right? Start left, go right. Here we started right. Started right and went left. All right. Good. So here we go. So we're going to take, let's see how many places we're going to go. 1, 2, 3, 4, 5, 6, 7. Now, because we're going in the opposite direction, right? Our power is actually going to be, remember when we're dealing with whole numbers, we're dealing with tens, hundreds, thousands, 10,000s. And when we're dealing with decimals, we're dealing with tenths, hundredths, thousands. And if we remember our rule of exponents, right? If we have 1 over 10, that's the tenths. 1 over 100, the hundredths. 1 over 1,000, 1,000s. If we were to write this in the power of 10, as they suggested, we write between 1 and 10, and then we write in the power of 10. Remember, if I have to write 10, then it has to be the reciprocal. Then my exponent here would be negative. Remember what we learned about negative powers? This would be negative 10 squared. 10 to the negative cube, right? 1 0, 1 power 2 zeros, 2 power 1, 2, 3. And because we know that 10 1 is 10, 10 squared is 100, 10 cube is thousands, right? But because it's the thousandths, because we're working with decimals, so you guessed correctly that when we write our exponential, it'll be 5.67 times 10 to the, how many places we went again? 1, 2, 3, 4, 5, 6, 7. Let me number that. 5, 6, 7. So that will be 10 to the negative 7. All right. So when we're converting decimals to scientific notation, our power is to the negative 10, negative power, negative 10 to the negative power. And when we're doing whole numbers to scientific notation, our exponent will be positive. Okay, so that's all there is to this, the scientific notation. So our next video, we're going to get into our division of polynomials. Again, a nice slow introductions to factoring. So far, we've done addition, subtraction, and multiplication of polynomials, and we did scientific notation. Now we're going to be doing division in the next video.